Greetings, Graham Warren again. I'm working with you on the AnyLogic simulation model for the hip hop case. So this is a discrete event model, and AnyLogic also does agent-based models and systems dynamics models, but what we're working with here is an example of a discrete event model. So I want to go through the logic with you and explain some of the possibilities sort of built into this model. So Hipkins has 4 ORs, and they're laid out in 2 tracks. We've got the A track, which you can see up here, and then the B track. So there's 2 ORs in each, and then there's 1 anesthesiologist and 1 surgeon assigned to each. So I'm going to go through the pools first, just so that you can see really who the players are. There are going to be patients that are going to run through here, and then they're going to get served from these pools. So the registrar pool is composed of 2 registrars, and you can see that I have a resource unit typed by the name of registrar, and there are 2 of them. And then in anesthesiology, anesthesia pros A, this is a pool of anesthesiology professionals. There's just 1. So when there's 1, it'll typically have to be an anesthesiologist by law and by hospital policy. But notice that the type is just a generic anesthesia pro. So we've got the same down here, again, an anesthesiologist, but we're just calling it person anesthesia pro. And if you did add another person, of course, you could add an anesthesiologist, or you could add a CRNA or an anesthesiology assistant. So basically, as long as the anesthesiologist is present and supervising, you could have a CRNA or an anesthesiology assistant with the patients in 3 different rooms in each case. So what this allows you to do is, if you did have 2 patients that were sedated, you could have 1 anesthesiologist and 1 CRNA. Or maybe 2 CRNAs and 1 anesthesiologist, and that may be cheaper from a staffing perspective than hiring an extra anesthesiologist. Right, so that's the anesthesiology pros. The same type in both pools, but this top track, those 2 ORs are going to pull from that pool, and the bottom one is going to pull from this anesthesia pro B pool. Same thing with the surgeons. There's 1 surgeon. They're generic surgeons as a resource type, but there's 2 separate pools of them. And track A pulls from the pools PULL from this one, and the second group here, the second track pulls from this pool POOL. All right, then as far as the operating rooms, same thing. There's 2 ORs here for track A and 2 ORs for track B in the generic operating rooms. And then we've got an EVS pool. So these are the environmental services that come in and clean the ORs. And there's 2, and they serve both tracks. So the registrars serve both tracks, and so does the EVS pool, but the others are dedicated. Now, one of the questions we're going to have is whether that actually makes sense. Do we want to maybe pool the operating rooms and maybe pool the anesthesiology pros? Those are questions we can ask, and I'll show you how to assess those innovations in the process. All right, so I'm going to do a quick model walkthrough for you so you can see how all this is laid out, and we will look at the details. So I'm going to take 1 track and go all the way through now. So patients arrive every 90 minutes. Excuse me, every 90 minutes. Yeah, that is true. Every 90 minutes. And then we start a timer on them. So I just want to note I'm using the truncated normal distribution here. So if you haven't seen this before, the idea is, if we have a normal distribution centered at 90 with a standard deviation of 5, there is a possibility that we could get a negative number. But this structure here, where I put in the min and the max, 0 and infinity, just means that if you do get a negative number, what's going to happen is the software is going to come in and resample from the distribution until it gets a positive number. So this is the mean, And this is the standard deviation. So let's clear this. And I'm going to need to go and make sure that this one is consistent as well. So let's just make this 90. Right, and so let's go back here. We're going to start the timer. We're going to call it, the patients incidentally are called agents. I could have created a new resource type, but the agent is the base case, and I just left it as is. So we start a timer on them, and then they go through registration, which we pull somebody from the registrar pool. We pull one person, and it takes 5 minutes for the standard deviation of 2. So again, I'm using this truncated normal idea with a min value of 0, so I don't get any negative registration times. But the mean is 5, and the standard deviation is 2, and it's expressed in minutes. From there, the folks wait for an OR to free up, excuse me. So I'm grabbing from operating room pool A, grabbing 1, and then from there we grab an anesthesiology pro. So if there's just 1 in the pool, that would be the anesthesiologist. If you add anybody else, it will presume to be a CRNA or an anesthesiology assistant, because it wouldn't make sense to pay for another anesthesiologist when you can staff backup using CRNAs. All right, now that anesthesia, it takes 25 minutes to complete. So this is the pre-op prep, and there's a standard deviation of 707. So where am I getting that from here? It's these two together, 20, 25, and then I'm using a the variance of the sum to get this this calculation going. 707. So the standard deviation of the one was 5 and the other one was 4, was 2. So 25 squared plus 2 squared is 29 squared root of 29 is maybe it's not 707. I'll have to review where I got the 707 from. Let's just check that briefly. So yeah, it was 5 and 5. So I'm not quite sure where the 707 comes from, but oh yeah, it's 5 squared plus 5 squared, that's 50. Square root of 50 is 7.07. So I'm adding the two means together to get the total anesthesiology. I'm just saying the anesthesiologist has to do all that work, and that's 25 minutes with a standard deviation of 7.07. Okay, so let's go back. We've got that anesthesiology process. Then I'm going to do the surgery. I'm grabbing a surgeon from surgeon pool A, grabbing one of them. Surgery takes 110.71, the standard deviation of 8.09, mean is 110. Again, that comes from the table here. So that actually should be 100. After I played with this a little bit, numbers change on you. But I'm hoping to save this up in the form that you needed. Okay, so from there, we're going to release the anesthesiologist. We stop the timer because the surgery is now done. And then the patient goes off to recovery and discharge or admittance to the hospital. We're not interested in the recovery process. We're going to clean the room, and we're going to use a member of the EVS pool, just one. And then again, we're using that truncated normal idea. The mean cleaning time is 40 with a standard deviation of 5. That comes from our table here. I've got 15 and 5 in here, so let me go and clean that up. Just put in 15 and 5. Right, and then from there, we release the OR, so then it's free again. So I'm just going to observe what that looks like. Operating room pool A gets released, and then we sync the patient. In other words, the patient's done from the perspective of the model. All right, so we've got some. So the bottom track is going to be identical. What I have to do is I have to clean up a few things here. So this was 100.71, right? And then this one at the end was sorry, cleaning was 15, right? Now, I'm not sure that they can actually get it done in 15. I seem to remember we had to adjust that to 40, but I'll verify that. Okay, so I think we're good. And then we've got some statistics that we're collecting. So we want the registration, excuse me, the registrar's utilization. So I'm using a statistics block for that. It's continuous samples, and I use this built-in function utilization on the registrar pool. Same thing for the cleaning pool. And in fact, all of these utilization numbers deploy that same function dot utilization, but just on the appropriate pool. And then finally, I've got histograms that I'm going to present for the two timers. There's a timer for A. It starts here and here. Notice that if I click on timer end A, yeah, it connects with timer start A, and so that's the beginning and end of your timer. And then I'm able to get the histogram from that using this dot distribution function with time end A. And the second timer has the same structure. Okay, so this is the basic model, and it took me some time to debug it, and I certainly evolved it over a few months with experience from a previous class, and looking forward to exploring some scenarios with you with this one.